Now let's write our own exception type. But you may wonder, we have all of these unchecked exceptions in Java. Why not just reuse one of those? And indeed, you could do that. And that's what we're doing here with this example. But sometimes when your program encounters something, or you want some event to take place, then the built-in Java exceptions are not sufficient for what you want. So you can write your own exception that designates that kind of event occurring. Okay? So, for example, let's say we want to write an empty array exception class. So we can just do empty array exception. And what we're going to do is we're going to make it extend the runtime exception class. This is the superclass of any exceptions that can be thrown, as it says, during normal operation of the JVM. Runtime exceptions and subclasses are unchecked exceptions, and we're going to create an unchecked exception. Okay? So we can create the constructor, and we'll just say, so what do we do from here? Well, the first thing we can do is say we can change this to be a throw new empty array exception, and then, well, okay, we can run this, and then we would need to change this to be an empty array exception, and then everything would work as expected. But what if we want there to be, so like what would happen if we just ran this code and like we wanted to print out the array? So this should cause an exception, and it does. But now we don't have really any good information here. Like we only have the exception type and the stack trace. But what if we want a little message to pop up? Well, we can call the runtime exceptions constructor via super and pass in some message. So we can say array is empty, something like that. And now this will pop up with array is empty. Okay? So this is a pretty bare bones, straightforward way of doing it. But another reason why this might be helpful is because a lot of the built-in Java unchecked exceptions are negatively associated. And what I mean by that is that they often describe bad things that happen, like input mismatch exception, arithmetic exception, things like that. But remember, I said that, a couple videos ago, I said that exceptions are control flow operators, and that's it. That's all they are, okay? They don't have to necessarily be associated with something that is bad. And indeed, one thing that you can do is treat exceptions as ways to get from one location to the next. Okay? And in particular, in the book, I talk about an example of using or writing a linear search algorithm, or just a searching algorithm, using recursion. Remember that if you just write, in the base case, if the array is empty, return -1, then you will cause the stack trace or the recursive calls to unwind, and then you'll get an invalid result. Okay? And that's not good. Instead, what you can do to avoid the stack unwinding at all is just throw an exception. Throwing an exception will cause the entire stack trace to be wiped out. Okay? And that's pretty convenient if you want to forego having to do all of that stack unwinding. Okay, so that's just one example. Another example is that you can model something called continuations with exceptions. Okay? And continuations are a much more advanced control flow operator, and something that we won't talk about in this course, but if you're interested, you can certainly look it up.